Hey guys, in this video I'll be going over questions with the AMC8 2000 test, problems 16 to 20. Last video we went over questions 1 to 15. If you haven't watched that video, make sure to watch it. It's linked in the descriptions below. Let's get into it. Problem 16. In order for Mateen to walk a kilometer or 1,000 meters in his rectangular backyard, he must walk the length 25 times or walk its perimeter 10 times. What is the area of Mateen's backyard in square meters? So we can just draw a rectangle, and this is Mateen's backyard. And this longer side is its length, and the shorter side is its width. So they're saying that to walk a kilometer or 1,000 meters, Mateen can go across this whole length 25 times. So 25 times the length is equal to 1,000 meters. Or you can go across the perimeter, which is just 2 times the length plus 2 times the width, 10 times, so times 10 is also equal to 1,000 meters. So then we can simplify both of these equations to find the length and the width, which will be used to find the area. So we can simplify the top one first. We can divide by 25 and get 40. The length is equal to 40 meters. And bottom one, we can simplify this. First divide by 10, get 100 on the right side, and then divide by 2 again, and then get 50 on the right side. So now we have length plus width is equal to 50. We can substitute this equation over here and get 40 plus the width is equal to 50, and then we get the width is equal to 10. And now that we have the length and the width, we can multiply them to get the area. So 40 times 10 is equal to 400. So our answer is C, 400. Now, next problem, problem 17. The operation, I'm going to call this x. X is defined for all non-zero numbers by aXb is equal to a squared over b. Determine this equation. So first, let's solve the left side. In the left side, the innermost parentheses say 1x2, which is equal to 1 squared over 2, or 1/2. Next, we have 1/2 x3, which is just 1/2 squared over 3, which is 1/4 over 3, which is also equal to 1/12. So then this left side is 1/12. I'll just write this over here and then erase everything in the bottom. Then on the right side, in the innermost parentheses, we have 2x3, which is also equal to 2 squared over 3, which is 4/3. Next, we have 1x 4/3, which is equal to 1 squared over 4/3, which is 1 over 4/3. And this is also 3/4. Now the right side is 3/4. So our final equation is just 1/12 minus 3/4. Now this immediately crosses out C, D, and E because this is obviously going to give a negative number since 3/4 is greater than 1/12. And so we can find a common denominator, and the common denominator is 12, so we can multiply this by 3 and get 9 over 12. So then 1/12 minus 9/12 is negative 8/12, or negative 2/3. So our answer is A, negative 2/3. Let's move on to the next problem, problem 18. Consider these two geoboard quadrilaterals. Which of the following statements is true? A says the area of quadrilateral A is more than the area of quadrilateral 2. Area of quadrilateral 1 is less than the area of quadrilateral 2. The quadrilaterals have the same area and the same perimeter, and so on and so on. So they're basically comparing the perimeters of the quadrilaterals and the areas. So let's just figure those out before we check out the answer choices. So for quadrilateral 1, the area we can find by just dividing this into 2 parts. And then we see that these are 2 congruent triangles. So then if we flip this triangle over here, we can actually find that this make a perfect square. So this is actually equal to 1. The area of this would be 1, assuming that these dots are 1 apart. So we can just write the area of, let's just say Q1 is equal to 1. So now let's find the area of Q2. The area of Q2 is actually pretty easy to find. We can just we know that the base of the top part of it is 1, and the height is also 1. So then we find the area of that top triangle, this triangle over here, using the triangle formula, which is base times height times a half. So 1 times 1 times a half, which is just equal to a half again. And then we can do the same thing for this bottom triangle over here. The base, we'll just say this top part is 1, and the height is 1. And then this is the same thing as this. So we get a half, a half, plus a half, which is equal to 1 again. So we see that the two areas are the same, 1 and 1. So this immediately crosses out the first two answer choices, because these say that one is greater than the other. Next, we have to find the perimeter. So let me just write perimeter. I'll just call it pre. And then Q1. What's this one? Q1. So to find the perimeter, we have to use the Pythagorean theorem to find the perimeter of the lengths of these slants. So we can use the Pythagorean theorem, and then we can find the two legs, which are just 1 in both. So let me just recreate it over here. 1 and 1, and this is what we want to find, so I'll call this x. So we can just do 1 squared plus 1 squared is equal to x squared. We get 2 equals x squared, and then x is equal to the square root of 2. So we know that side. Let me just erase everything here. This side over here is equal to 1. Now we need to find this side, but these two sides are actually the same. Sorry, not 1, square root of 2. These two sides are actually the same, so this side is also square root of 2. And then the two remaining sides are over here and over here. So these are actually straight lines, so you can just tell this is 1 and this is 1. So our whole perimeter is just 1 plus 1 plus square root of 2 plus square root of 2, which gives us 2 plus 2 times the square root of 2. Now let me just simplify all of this and write this. The perimeter of 1, why did this disappear, of this is equal to 2 plus 2 times the square root of 2. Okay, lots of 2's. And now we need to find the perimeter of quadrilateral 2. So for this has 4 sides, like that one. But in this, there are 3 slants. So first, let's find this long slant over here. So again, we can use the Pythagorean theorem. Let me just redraw it over here. Okay. This slant is this one. So we'll call this x. And then we see this is 2 units. So 2 units. And then the height is 1. So 1. So then we can use the Pythagorean theorem. 2 squared plus 1 squared is equal to x squared. So we get 5 is equal to x squared. And then x is equal to the square root of 5. Okay. Just erase all of this. So then this is equal to square root of 5. And now these two are actually the same things that we did over here. So then this is just square root of 2, square root of 2. And then this is just a vertical line, which we know the height of is 1. So our final perimeter is just 1 plus 2 square root of 2's plus a square root of 5. So let me just write it here. Perimeter of quadrilateral 2 is 1 plus 2 times the square root of 2 plus square root of 5. Okay, good. Now we can look at our answer choices. So, answer choice C says that quadrilaterals have the same area and the same perimeter. This is obviously not true because this over here, just scroll down, this over here is not the same as this, okay? So C is wrong. D says quadrilaterals have the same area, which is true, but their perimeters of 1 is more than the perimeter of 2. This is wrong because the perimeter of 2 is greater than the perimeter of 1. We can prove this right here because we'll just do 1 plus 2 square root 2 plus square root 5 is equal to 2 square root 2 plus 2. Now 2 square root 2 and 2 square root 2 cancel out. We'll subtract 1 and get square root 5 is equal to 1. Or I shouldn't say equal to, I say which one is greater. Square root 5 and 1. I'll just leave a blank sign. So then we can square both sides, and then we get 5 blank 1. So we see that 5 is obviously greater. So then we can just write 5 is greater than 1. So this shows that this one is greater, and thus E is the right answer. Now let's move on to the next question, problem 19. 3 circular arcs of radius 5 units bound the region shown. Arcs AB and AD are quarter circles, and arc BCD is a semicircle. What is the area in square units of the region? So this might seem pretty complex because you might know how to find this area over here, but what about this sliver? But this is actually a trick question. What you can do, you can divide this into 3 parts, like this. Let me just redraw it over here. You can redraw it like this, and like this. Like this. Now what you can do, since all of these have the same radius, you can shift this one over here, and shift this one over here. So it becomes a rectangle. Now this rectangle we can just find the area of, because we know the radius, or from this point to this point is 5, and then from this point to this point is also 5, and then from this point to this point is also 5. So then it's just 5 times 5 plus 5, which is 5 times 10, which is equal to 50. So the answer is C, 50. Now let's move on to the next question, problem 20. You have 9 coins, a collection of pennies, nickels, dimes, and quarters, having a total value of $1.02. With at least 1 coin of each type, how many dimes must you have? So basically you have 9 coins, and at least 1 of each coin. So let's just first start with that. So you have 1 penny, 1 cent, plus a nickel, 5 cents. Okay, then a dime, 10 cents, a quarter, 25 cents, and then all of this adds up to 41 cents. And now, since these are 4 coins, and you can only have 9, so you do 9 minus 4, so now you can only have 5 more coins. And then $2 minus 41 is equal to 61 cents. So you have 5 coins to make 61 cents. Now obviously you need 1 coin just to get rid of this 1 cent over here and get an even 60 cents. And that 1 coin is going to be a penny. So 1 penny. And then we can just use trial and error to find how we can get this 60 cents. So a way I'm thinking is using 2 quarters. 2 quarters to get 10 cents remaining, because it's equals to 50 cents. And 60 minus 50 is 10. And then to get this 10 cents, we can use 2 nickels. So 2 nickels equals to 10 cents. So now at the end we have 0 cents remaining. So then we only used 1 dime. So our answer is A, 1. That wraps it up for this video. If you like this video, make sure to like and subscribe. If you have any questions, ask them in the comments below, and stay tuned for the next video.